Hi, in this video we would be solving two problems of finding time complexity again. So let's quickly delve into that. So in this first one, you need to find the time complexity. So these are a lot of loops going on. So try to pause the video and think about how would you find the complexity of this. Okay, so I'm assuming that you have thought about this. So what is happening over here? The I is moving from 1 to n, and for every I you are starting from 1, multiplying 2 again and again until you reach I, right? So you start with 1, you go to 2, you go to 4, you go to 6, you go to, sorry, 8, 16, and so on until you reach I. So how many such iteration will take for a particular I? So given any I, how many iterations from 1 jumping by 2 to 2 and so on will take you to reach up to I? Order log I, right? Is this part clear? That this takes order log I, because every time you think of this as the reverse way. Let's say you are at I, so before that, if at the xth step you cross I, at x minus 1th step you must have crossed I by 2. So you are now going down from I by 2, I by 4, so on up to I by some 2 to the power m, such that this becomes 1. So m is equal to log of I, right? Log 2 of I. And in log, when you're writing in order notation, the base doesn't matter, because base can be transformed into some other base and by dividing by some constant, right? So base doesn't matter in order notation. But in general, if we write or log in computer science related stuff, it's generally log 2. Okay. So this internal loop is taking order log I. Okay. Now how do we find out the total time complexity? So this is nothing but summation of order log I from I equal to 1 to n, right? Now this is a weird summation, right? Like, how do you add logs? So in such cases you can think of it like this, like this is obviously less than equal to order log n, right? I is always less than n, so each of the order log I is less than order log n. So we can convert this summation, into summation of I equal to 1 to n order of log n, because we are only going above in the upper bound. So our bound might not be exactly tight, but again we are going a bit upper, so that's still correct, right? And now order log n is constant, so you can take that out. So order log n times summation of I equal to 1 to n times 1, that is equal to n. So this will become order n log n, right? So if you loop it this way, it turns out to be order n log n, right? So this total is order n log n, right? So that's done with the first problem. Let's now move to the second code. So try to think about the second one now. This is quite similar to the previous one. So pause the video right here and we'll be looking at the second one after you have thought about it. So I'm assuming that you have paused the video and have thought about this. So do take these pauses seriously. Try to solve them. Let's now look into how you can think about this problem. Okay. So in this case, what is this internal loop doing? You need to think about that. So it's starting from I, and unless it goes up to n, it keeps on adding I, right? So how many times this loop runs? You start from I, you keep on adding I. So you started I, you go to 2 times I, you go to 3 times I, so on up to x times I, such that less than equal to, it gets greater than n, right? This number has to be greater than n. So x has to be greater than n by I, right? And x is the number of iteration, because this is 1 2 3, that many iteration, right? So n by I number of iteration is the number of times this loop runs for a particular I, right? So now once we know this, we now know that this part takes order n by I. Now what is this total part taking? So this will be nothing but order n by 1 plus order n by 2, so on up to order n by n, right? Now if you think about this properly, this is nothing but order n times 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, so on up to 1 by n, right? Now in general, this summation over here is bounded by order log n. Okay? So this harmonics are generally approximated using log n, like nth harmonic, sum of first n harmonics of n is generally uh, quite close to order log n, in fact. So we can bound this by order log n, and we can write the final complexity for this as order n log n. Okay. So again, for this problem, we found out that the time complexity for this total comes out to be, like, this total would be order n log n. Okay. So these were two interesting problems, like when you are looping to multiplying by 2 again and again to reach to some I, and then you are looping over from 1 to n. So this takes you order log n for each of them, each of the internal ones. That's the main observation that you need to understand. Sorry, log of I, but again we can bound that by n. Okay. And then in this one, if you keep on multiplying, it takes n by I. So summation of n by I from 1 to n, this is the harmonics, and this is bounded by order log n. This is a property that you need to understand and know, to be precise. So with this property in place, that this sum over here is bounded by this order log n, we can say that this will be order n log n. Okay. So these are two n log n codes. These codes are very helpful. We'll be discussing about them in details later on. Okay. That's all for this video. Thank you.